Hi and welcome back to the channel, and in today's video we're going to take a bit of a deep dive into getting software loaded onto my Apple IIe here. In the previous chapter in this series we took a look at getting the IIe setup to display video. Pretty basic. If you don't have video you can't really do much, and by the end of that video we managed to get pretty good quality video out of it via HDMI using a card called the VidHD. So with my Apple II in that state, I can't really do that much. I can type in programs in BASIC, and if I wanted to go really old school, then I could actually save out or load in programs from a tape deck. For instance, this one here actually came from a purchase that I made last year of a BBC Micro. I've not actually used it yet, but it's pretty typical of a tape deck from back in the day. And it has an audio in and an audio out, and that would allow you to use it with this Apple II to actually load and save software. But luckily, we don't have to go there. And the reason for that is one of the standout features of the Apple II story happened very early on in its life. And that was the creation and release of the Apple Disk II floppy drive system. So let me show that to you. It's actually not quite just these items, it's also software as well. I'll explain that a little bit later. The system consists of a card. This is the controller card, and that gets placed inside the Apple II. And then you have the drive itself. It's a pretty old model. It's actually from about 1976, I think it was, that this was actually released. Not this particular one. This is Apple's own interpretation of it. But yeah, it's a bit of a historical drive, let's put it that way. One of the first 5¼ inch drives that was actually released for microcomputing. So a pretty interesting device that we're going to actually look at today. It's going to be fascinating, so please stay to watch. In the summer of 1977, Steve Wozniak was cornered in a meeting at Apple by Mike Markula. Markula was one of its early investors, and he had a check balancing app which he used quite often. Mike was not happy that it took 2 minutes to load in the software and then another 2 minutes to load in his personal check file. Mike said it was a grind. And Mike felt that most other Apple II users were going through the same kind of frustration as he was. He made a very strong case for the next big project at Apple to be a floppy drive system for the Apple II. Steve Wozniak, he'd used floppy drives when he was working at Hewlett-Packard, where he had worked between 1971 and when he left to found Apple in 1976. Wozniak knew that as it was, using a tape drive really limited the use of the Apple II. Most serious users, including business owners, would not take the machine seriously unless it had a good, working floppy disk solution. Until that point, the Apple II would be seen as something of a hobbyist machine only. So Mike's case was pretty impossible to argue against, and everyone agreed the floppy project was a priority. So Wozniak set about engineering the system. Whilst he had been at Hewlett-Packard, Wozniak had come across a technical manual for a Shurgard floppy drive. And when this interest peaked, he had undertaken a small project to make his own controller board to replace the standard electronics inside the Shurgard drive. Now, to give this some context, Al Shurgard had been an engineering lead at IBM working on hard disk solutions. But then he had left IBM in 1969, and in 1973 he had founded Shurgard Associates with a mission to produce a cheap 8-inch floppy drive, which then went on to be a big success, especially in the extremely nascent microcomputing market with machines such as the Altair 8080. In 1976, Shurgard released a new, revolutionary smaller model, the SA400, based on smaller 5¼ inch floppy disks. These in turn proved to be very compelling due to their much smaller size and therefore cost. At Hewlett-Packard, Wozniak's first own controller design was very Spartan. Just 5 chips were required to make this design work. This troubled him as he assumed he had left out quite a lot of features. However, his replacement electronics did actually work, so he was satisfied and he parked the project for another day. So just before the Christmas holidays of 1977, just 6 months or so after the Apple II's initial release, Steve dug out that old project and set about evaluating it for the Apple II's new disk system. He was still troubled that he had left out some key features, so he painstakingly compared it to a North Star drive, and when his review was complete, he concluded that his design wasn't really omitting anything. If anything, it was more capable. And yet what was amazing was that his design had reduced the controller from 50 chips to just 5. So he reviewed it with the rest of the Apple team, and the go-ahead was given to push on with the project. Steve Jobs was then dispatched to visit Shurgard, and being Steve Jobs, he demanded they sell him an SA400 drive mechanism for just $100 each. To justify this, Jobs said he would not need any logic electronics on them, just the bare units, and that also certain sensors would be omitted, as well as the head-load solenoid, which was a feature that the SA400 drives inherited from their 8-inch predecessor. Jobs said he wanted bare-bones units. So Shurgard agreed, and they shipped 25 of these stripped-down units to Apple, which they badged as a new item, the SA90 drive mechanism. On receiving these, Wozniak and Randy Wigington, another engineer at Apple, then spent the whole of the Christmas holidays hammering out this controller to work with these sample mechanisms. Along with the in-drive controller, Wozniak knew another controller card would be required inside the Apple II itself. Otherwise, how would you connect the two together? Because of the Apple II's 8 expansion slots that we looked at in the last video, Steve had a way into the system. It would be a card, which would plug into one of these slots, and then the cable from the disk drive could then plug into it. Again, Steve produced that card, and that design is as frugal as the electronics inside the drive itself. So by the end of the Christmas holidays, Steve and Randy had a very basic system ready to demonstrate at 1978's Consumer Electronics Show in Las Vegas. This was a massive event where he would be able to showcase this new piece of equipment. And at the event, it of course caused a massive stir with the growing Apple II user base. Apple knew it had a hot new product on its hands. The next phase was to produce a working disk operating system for the drive. Steve Wozniak had no experience making a disk operating system, and to be fair, his hands were really full just making the electronics for the hardware. So they brought in an external company called Shepherdson Microsystems, and they hired them to produce the disk operating system for them. In a remarkably short space of time, Steve Wozniak and the rest of the Apple team had the hardware for the disk drive system ready for launch in June of 1978. And Shepherdson Microsystems delivered on their contract, supplying a professional working disk operating system. This turnaround had taken them just 7 or so months after Mike Markula had made his case. Apple decided to call the drive the controller card and its DOS the Disk II system, linking the 2 in its name with the Apple II's name. It initially sold for a discounted pre-order price of $495 US, and when it went on into general release in June of 1978, it sold for $595, which is the equivalent of $2,956 in 2025. I know this price may seem crazy by today's standards, but back in 1978, this disk system was the cheapest available on the market by far. And yet at the same time, Apple was able to produce it for 1/3 of that price, making the Disk II system a massive money spinner for them. Some people say that the development of the Apple II computer was an act of genius by Steve Wozniak. Indeed, it appears prodigious that pretty much a single engineer could produce such a complex design on his own. But if the Apple II is genius, then the Disk II system is even more so. Why? Well, you've got to remember, Al Shurgard was a lead engineer at IBM's storage division, and when he formed Shurgard Associates, his 8-inch floppy drive and later his 5¼ model were market leaders. They were state-of-the-art. And yet at 27, still basically a journeyman engineer with no direct track record in engineering disk drives, Steve Wozniak came along and produced a controller design that massively simplified the contemporary designs, and whilst at the same time producing a superior performance and capacity. The drive is definitely a work of genius. Even to this day, Wozniak says that the disk design was my most incredible experience at Apple and the finest job that I did. So let's take a look at installing a Disk II system. But before we do that, let's have a quick word from our sponsor, Justway, the easiest way to custom parts. Justway offer CNC machining, 3D printing, injection molding and sheet metal manufacture. Just go to the Justway website, define your project and get an instant quote. It really is that easy. So remember, head over to Justway to get your project manufactured just the way you want. Let's put these out of the way so we can get the system installed. I'll just put this over here for a second and move the drive out of the way. We need to take the top of the case as well because we have to install the Disk II card. So let's take the lid off. Okay, there we are. Right then, I want you to come in a little bit closer because I'm going to have to show you the card. So this is the Disk II interface card. As you can see, it's got the legend top left there on the card. And on the left-hand side of the card, hopefully you can read there, it says copyright 1978. So we really are going back in time here with this vintage piece of electronics. On the right-hand side is the business end of it. It's got two connectors there. You can see they're numbered. It says 1 on the top and 2 on the bottom. So yeah, your first drive will be plugging into the top connector there and your second drive into the bottom one. This is referred to in DOS as being device 1 and device 2. On the card, as you can see, it says drive 1 and drive 2. They are the same thing. I guess the idea is that maybe they were going to allow other devices to plug into this card, possibly. I'm not really sure, to be honest. There is a bit of a problem with this particular design of connector. Let's get in a little bit closer. And what I'm going to actually show you is how you actually plug the drive into the card. That may sound like a no-brainer, but believe me, it isn't. Okay, so we've got our DIS2 interface card here. I always call it a controller card. Yeah, you know, if I say controller card, you know what I mean. So the most important thing that you need to know about with this card is that, number one, these connectors here should be at the back of the case. So when you put it into the slot, you make sure that these are towards the back of the case. That's the correct orientation for the card. Number two, you've got to be very careful when you're plugging in the disk drive. Now, earlier on in this video, I said that this was a work of genius. Well, it turns out that genius sometimes is flawed. And in this case, the problem is that they didn't key this connector. And that was a big problem back in the day. I'm sure it damaged many drives, and you'll see why in a second. So I'm going to show you the connector at the end of the ribbon cable from the DIS2 drive, which is just there off camera. And if you have a look at this connector, you can see that it doesn't have any keying on it whatsoever, at least physical keying, the kind of keying that we came to expect as standard later on with floppy drives, for instance, in IBM PCs, Amigas, and things like that. Now, it does actually have some keying. There is a red line here, and that red line indicates that this is pin 1 on this connector, and the pin 1 here on the connector on the card is over here on the left. So you can see that we have two connectors. This is for the first drive, it says here, drive 1, and the lower one is for drive 2. Apple also refers to these as device 1 and device 2. It's the same thing. So we're going to try and plug this in here. So you've got to make sure that the red line is aligned with the left-hand side of here, where it says 1 there. And then you can see it pushes up against the PCB and it plugs in. Now, that may seem like a very easy thing to do. It's actually very easy to get it wrong when it's plugged into the machine. And the reason for that is when it's plugged in, this is very often what you see. You can't see the pins as you're plugging them in. And it's very easy, for instance, to do this. Do you see how there I've got them offset one row? From above, that's what you see. And I know it looks silly, but if you're tired, and especially if your eyesight isn't good, and for many other reasons, you know, if you're in a rush and things like that, it's very easy to do that. And it's also equally easily to do this as well. You could offset it one row like that and push it on. Yeah, there's just so many different ways that you can actually do this incorrectly. Now, there is another problem. This device here, which is a floppy emu, this is a disk drive emulator for the vintage Apple series. You can see it's got a Mac on there, but it actually does Apple II emulation as well. And it also does the 2GS. Very, very useful device. And we'll be looking at this a little bit later in this video. We're not going to go into it in any depth, but we're going to use it because I only actually have one DIS2 drive. So I'm going to demo some stuff later where I need two drives, and this is going to be my other drive, as it were. Now, if we have a look at the ribbon cable on the other end of this, you'll see that this one actually is keyed. See that little nub there? Well, that is meant to fit into a little box here with a key in it. So I believe you can get these cards with those boxes on. That makes things a lot easier. However, with the original connector, as I showed you, there isn't actually any physical keying, so that's not going to really help you. And there is another thing as well. Let me just show you this, and this can help really confuse things. Do you see the way that we have the red line on this side of the cable and we have the red line on this side of the cable? But you can see that here, this is the floppy emu connector. The cable goes into the bottom of the connector, and you can see that with the original DIS2 drive, it goes into the top. So that is easier to plug in because, as you can see, the cable is on the outside. But on this one, it's on the inside. So despite this key, you might think, oh, well, it's got to be that way around. You know, the cable must be on the right outside. Maybe you remember that more than you remember the red line. Yeah, don't make that mistake. For the floppy emu, you would plug it in like this. So for example, let's say we want this to be the main drive, in other words, drive 1. we would plug this in here. There we are, it's on the right row of pins. And then this one here, again, making sure that the red line is on the outside there, we would plug it in like that. And then this would give us the floppy EMU as disk 1, which is our boot drive. And then this would give us my disk 2 drive here as basically a slave drive. That would be the second device, or as it says here, disk 2. So this is ready to go in the machine. An interesting thing about these cards is that you can actually have multiple cards. Now, I must admit, in the past, I actually have damaged these, and because of this, I actually have 4 of these. Yeah, you don't want to ask. But right now, I know for a fact that this controller here and this controller, they both work. So what I could do if I wanted to was actually put, let's say, the disk 2 drive here, and then I could plug this into another slot. So I could actually have just one drive run off each card and have them in separate slots if I wanted to. In fact, as far as I understand it, you can have one of these controller cards, I think, in every slot apart from slot 0. Slot 0 doesn't really exist on an Apple IIe, but on an Apple II and an Apple II Plus, it does exist. And as far as I understand it, this works in every slot apart from that one. So that would give you 7 slots that this could go into. So potentially you could have 14 drives hanging off your Apple II. I believe that's a possibility. I'm not sure how well the power supply would handle having 14 drives, because an important thing to remember about the Apple II is that the disk drives themselves do not have a power supply built into them. They actually get their power from the Apple II, which is very convenient. But as you can imagine, if you're hanging 14 drives off the computer and they're all running at the same time, that would probably be a little bit problematic. Although, thinking about it, I guess because the CPU is used extensively in data transfer, I guess they wouldn't all run at the same time. So yeah, I guess you could go ahead and have 14 drives if you really wanted to do that. Yeah, a sort of super tower of power. But anyway, yeah, that's an important thing to remember. You can have multiple cards. Anyway, I hope all of that helps. Let's move on. Okay, so this little tangled web that we have here, this is going to be the configuration that we're going to go with. So we've got our controller card. In the top connector here, we've got our floppy EMU connected. So that's going to be our main drive, bear that in mind. And then in the lower connector, we've got our actual lovely disk 2 drive here. This is the only one I own, so that's why I'm using the floppy EMU, as I said. This is going to be plugged into slot 6, so I'm going to do that now. You've got to make sure that these connectors are towards the back of the case, because these cables would normally go out through a slot here. I'm not going to do that in this video, but if you were setting up your machine to have a permanent setup, that's how you would do it. You would actually put the cables through here first. I would then advise you to plug them in, as I said earlier, with the card actually out of the slot so you can see clearly what you're doing. And then when you're happy, plug them in as I am doing here. So that's at the back. I'm just rocking that in. There we are. That's nice. Next, I'm just going to orient my disk 2 drive to get in the right position. Try and put the cable at the back here. It's just out the way. And then I'm going to do the same thing with my floppy EMU. One of the minor criticisms I would have of the floppy EMU actually is that it's so light, it has a tendency to fall on the floor quite a lot. But I'm not sure what they would do about that in the design. Maybe I should put some lead weight on the back of this case, I'm not sure. But anyway, we are now ready to go. So one other point, the order of the slots does actually matter. So right now, this card is in slot 6, and that means it would boot after another card if that were to be plugged into slot 7. So the boot devices actually go down from slot 7 downwards, which is an interesting feature. I don't know why Apple chose exactly for the disk 2 card to go into slot 6. I guess it does give them somewhere to go, you know, in terms of higher priority. So later on in the evolution of the Apple II, there were actually hard disks. And generally, when you're setting up an Apple II with a hard disk, you actually put the controller card for a hard disk into slot 7. And that would mean it would be the primary boot device on the machine. It would boot up using the hard disk. And then your disk drives would then become secondary devices to your hard disk. So we've got our disk 2 drive. We've got our disk 2 card, which is plugged in. We've got our second disk 2 drive here, this floppy EMU that we're going to use as our boot device. So what we need to do next is to look at Apple DOS. Now, this system doesn't really fully function without Apple DOS. And as we said, Apple got that external company to write it. So what we're going to do next is we're going to show how the hardware and the software work together to make the Disk2 system. Okay, I've made a small change of plans here. What I did very quickly is I've swapped over the cables for the floppy EMU and the Disk2 drive, and that means that the Disk2 drive is now the primary drive on this machine. In other words, it's the drive that you would actually boot from. So what I want to quickly explain is something that foxed me a little bit because I didn't read the manual. In fact, this is why I'm making this video, because when you pick up the Apple II, you're completely fresh to it if you've never used one before. And it can be a little bit confusing, and that's why I made this series. It's to try and explain some of the mysteries of the machine, which if you were a user back in the day, you probably would have evolved with the machine, and you would have bought the Disk2 drive, you would have used it, and maybe it was even your business machine for a while, and that's why you became familiar with it. But if you come to it fresh in 2025 especially if you're a younger person, some of the things about this system are a little bit confusing. And one of the areas of that I would say foxed me at first is that it's important to remember that both with Apple DOS, the version that I'm going to show you now, and with its successor, Pro DOS, that neither of these actually reside in the ROM on your machine, and they do not reside in the interface card either. And what this means is that none of its commands are actually available for you after a hard reset of the machine. Apple DOS always has to be loaded from disk before its commands can be used. And this can be quite confusing if, as I said, if you've used the system without actually reading the manual first. So let me give an example of why it was confusing, because I've used a Commodore 64 extensively. That was my first big machine, I suppose, that I used for quite a number of years back in the day. And on that machine, when you have a 1541 disk drive plugged in and you type in catalog, it will actually do it. You don't have to load anything, it just works. And that's because Commodore engineered it so that messages are sent to the drive, and the drive itself actually understands those commands. Those don't actually have to be in RAM on your machine. So it gives the illusion that they're actually built in, but they're not. They do actually exist on the ROM on the 1541 drive, and they're loaded in. Now, in this machine's case, that isn't the case. So let me demo this to you. So I'm going to open up the drive. You've got to open it up before you can put a disk in. You've got to remember as well to close it when you want to read a disk. So I've got a copy here of the Apple DOS 3.3 master disk. This would have been a disk that would have come with the system, and you were meant to copy it before you actually carried on and used it. Not quite sure how you were meant to do that, because utilities would have been very sparse at the time. Anyway, if we put it in, there is a DOS command called catalog, and you've got to spell it the American way. So I'm going to type in catalog and press enter, and you get a syntax error. And that's actually perfectly normal. That's the way Apple DOS works. This disk does actually have that command on it, but to get it to work, you've actually got to boot up that disk. And we'll have a look at that a little bit later. So yeah, that's the way you do it. You actually put this disk in the drive and then you boot it up. Then once it's actually loaded, then you would actually have DOS commands loaded into RAM, and you'd be able to do some of the things that you might expect to do with a disk system like this. So you can imagine that, copying that master disk and then using it would have been a rite of passage for many users. I've skipped that step here. I've already made a copy of the disk. So I think what we should do is, before we move on and actually use it, I think I'll give you a quick explanation of the three main versions of Apple DOS. So on the Apple II, disk operating systems can be a little bit confusing because during its overall lifetime, there were actually two main systems. This was a common scenario actually on the Apple II. For example, you had the original integer BASIC, which came with the machine when it was launched. And this was soon superseded by the AppleSoft BASIC, which can handle floating point maths. A similar thing happened with the Apple II. The first DOS for the Apple II was called Apple DOS. It was Apple DOS 3.1 that was actually released, and this came along with the system in 1978. Internally, Apple developed versions of DOS running from 1 to 28. As we discussed earlier, this was actually carried out by an external company, but as they were evaluating these versions, they were numbered from 1 to 28. They were happy to go for release once they got to release 28, and they decided that they would introduce a point into that number, so it became release 2.8, if that makes sense. And they decided also that it would have been nicer, really, if they rounded up to a whole number. So they went for release 3.0 as being the release that was actually going to be launched with the Apple II drive. The thing is, they found a bug in it at the last moment, so then they had to actually increment by one. So as fate would have it, it was version 3.1 that actually was released with the drive. So Apple DOS and the physical disk drive and the controller, they were all developed together as a complete system. And indeed, if you actually read through the Apple DOS manual, you see in there, it actually shows you how to connect your Disk 2 drive and the controller card together. So you can see that Apple DOS would have actually come as part of the package when you actually bought the drive. It's actually in that section where it first tells you that you should install your interface card into slot 6. And because of this, this became the default location for the controller card. And it's for this reason that slot 6 is a location where you should actually put your card, because most software which was written for the Apple II did actually assume that you would have the interface card in slot 6. And very often, if you do not put the card in that slot, certain software will not actually boot and run. So that's something you should definitely observe. In terms of storage space, DOS 3.1 formats a disk to 113.75 kilobytes. Let's call it 113K. But about 10 kilobytes of that is used to actually store DOS itself. And that leaves you with approximately 100 kilobytes of space on the disk for you to use. Now, that may sound pretty tiny these days, but you've got to bear in mind that when the Apple II was launched in 1977, it actually only came with 4 kilobytes of RAM in a standard machine, in a standard configuration. You could actually purchase the machine in larger configurations all the way up to 48K, but the only problem with that was that you had to pay for it. A machine fitted with 48K on launch would have cost you an extra $1,340, and that is the equivalent to $7,163 in 2025. Yeah, RAM was crazy expensive back in the 1970s. It was a relatively new development, at least the type of RAM that microcomputers used, and boy, did you pay for it. So, as you can imagine, having 48K in your machine and then having 100K per disk, in other words, 2 whole applications worth of software on each disk, was actually perfectly adequate for the time. So something else to bear in mind about the Disk 2 system is that it had no way to actually auto boot when it was launched, when the machine is turned on. So for example, if I reset this machine and then reset it again, this is basically what would happen when you turned on an original Apple II or an Apple II Plus. You would turn on the machine and the disk drive would have sat here inert, not really going to do anything. Obviously, that would be a very useless system if you could actually boot a drive. So what you actually do is you activate the slot in which the card resides. And there are 2 commands that you can do that with. There's either in hash and then the number of the slot, or you can do pr, which as far as I understand is print, but it basically activates the slot. So this would have been very familiar to people with an Apple II. So what we're going to do is we're going to boot this up, and I'll show you how you would do that on an Apple II or an Apple II Plus. So we turn on the machine. I've just simulated that by breaking it straight after boot. And the reason for that I'll explain a little bit later. To actually boot a disk, we have to type in PR, which is print, and then the number, the hash sign I should say, and then the number of the slot, which in this case is 6, the default slot. So the way this works is this card gets activated. There's a little piece of software on that card in a ROM, and that gets activated when the card gets activated. That piece of software does a very simple thing. It tries to load a piece of software off the disk at track 0, which as far as I understand it is in the center of the disk to make it load faster. To do that, it gets the heads on the disk to try and go to track 0, and you'll hear it making a rattling noise because it positions the heads multiple times. The reason for that is that was one of the sensors that Wozniak asked to be removed. And to make sure that it's actually in the right place, it basically carries out the command multiple times to make sure that it's there. And then what it does is, when it's on track 0, it goes to sector 0, and it loads in sector 0. And it loads that into memory address 300 in hexadecimal in the RAM of the computer. At that point, the controller card then executes that memory location. That's like running a piece of software. And then that piece of code then executes, and then that then goes on to load more software off the disk. So the most fundamental part of this whole system is that you have this controller here that can actually execute that piece of code, load in sector 0, put that into RAM, and then from then on, it's just a case of reiterating that kind of process. It loads up another piece of software, which loads up more software, etc., etc. And this is why they call this a bootstrap process, where the kind of machine pulls itself by its own laces up into being ready to use. So I'm going to do that now. I'm going to press return, and what that will do is you'll hear the rattling noise, and then you'll see it will actually load up Apple DOS 3.3. There's the noise. I can hear the heads spinning away. There we are. We're ready to go. Now, one of the massive benefits of this approach is that the loading process is to a large extent left open to developers to adapt and change. It's only that initial load of sector 0 into RAM that is hard-coded into the interface card. Beyond this, it's actually up to you. Sure, you can use the Apple DOS loader to whatever degree that actually suits you, but if you know what you're doing, then you can adapt this code to load into memory in a way that you want. And it's for this reason that many games and applications took advantage of this approach to write custom loaders, which standard copy programs cannot actually handle. And this actually spawned a whole type of software called nibblers. That's not something we're going to look at in this particular video, but yeah, it's an interesting feature that because this system was so basic in a way, it became so flexible. So as I said earlier, you can't load up the contents of a disk and see what's on there. When you actually cold boot, you have to load in Apple DOS into RAM. It's ready to do that now. So if we type in catalog, press return, you'll see it's accessing the disk. And I just have to press return just to see the last file. And as you can see, it's actually loaded up the contents of the disk to display. And you can then go ahead and carry out the rest of the DOS commands on this disk and any other disk, obviously, once you have DOS loaded into RAM. Now, as we saw, when we booted this, let me just do that quickly. This machine does actually have auto boot, but I'll explain about that later. When it boots up, we're booting into DOS 3.3. So this is the latest version, the newest version, I should say. We'll talk about that in a second. But before we do that, let's move on and talk about Apple DOS 3.2. So in 1979, Apple released a new version of DOS, DOS 3.2, which introduced a much demanded auto boot feature, along with some new features, of course. Along with the software update, a new firmware was developed, which could be added to the Apple II ROM to make it auto boot. For this to happen, you just put a disk in the drives, as we just saw, and turn it on, and off it would go. This new ROM was loaded as standard into the newly released Apple II Plus, but this meant that the original Apple II was left out in the cold a little. As a result, Apple sold an upgrade ROM for the Apple II, allowing users to install that and then get this auto boot feature. Now, my Apple IIe was released in 1983, so it has this additional ROM already built in. So as you saw, we can already auto boot with this machine. So if I reset on this machine, it will actually auto boot this disk, as you might expect. Fantastic. So with that, let's move on and have a look at Apple DOS 3.3. Next, we have Apple DOS 3.3, the DOS that we've been using here, and this was launched in 1980, and this was actually a massive update. Its biggest feature was that a new disk encoding method was used, fitting in 16 sectors per track, rather than the original 13 which had been used in 3.1 and 3.2. This increases formatted disk space from 113K to 140K, and it's this format that went on to become the standard for Apple DOS ongoing. I mean, after all, who's going to turn down 27K for free? Another change, though, under the hood is that the interface card's ROM code was changed to load the sector 0 code from memory location 800, rather than the 300 that we saw originally. Amongst other features, this version also came with a disk utility called FID, to copy single or groups of files, as well as a utility called Muffin, which allowed you to transfer files from the earlier disks, which had 13 sectors, to the newer format with 16 sectors. Okay, so what we're going to do next is we're going to move on and take a look at using DOS commands. And we're going to do this using this copy that I've made here of the Apple DOS master disk. This was a copy that I made earlier. Once this is booted up, we will actually have our DOS commands to use. So let's do that now. So we'll just pop this in the drive, turn on the machine, and because we have an Apple IIe here, it will automatically boot. There it is there. And in a second, the screen should come on. It's just the A2 DVI card, which is taking a second to boot up. And as you can see, it's going through the boot process. And there we go. Everything has actually loaded up. So once the Apple DOS master disk is finished booting, most of the core DOS commands you might expect are actually in RAM and they are ready to use. However, there are a few other commands which you will need utilities for. Specifically, copy is quite unusual actually in that it's not part of the core commands available from the basic prompt. But there is actually a utility for getting that, so it's not that much of an issue. Now, there is something else I have to explain as well, because this aspect of the Apple II can be a little bit confusing, and it's to do with the history of the machine. When the Apple II was launched, and all the way up to the Apple II Plus, the Apple II only actually supported uppercase text. Apple DOS was released in this era, and as a result of that, the basic commands which are built into Apple DOS only actually work with uppercase characters as well. That can be a bit of a problem because you can think that you are using an Apple IIe, and with the Apple IIe, support of lowercase characters was added. That means you can type in basic programs in lowercase and they will actually load and execute and so on and so forth. However, if you try and actually use DOS commands in lowercase, it's not going to work. So you've just got to remember this. You've got to make sure that when you type in Apple DOS commands on any Apple II, as far as I understand it, you must have them in uppercase. As I said, on the Apple II and Apple II Plus, this is a non-issue because those machines, they only support uppercase. But with the Apple IIe, the best way to get around it is to actually turn on caps lock. So on the keyboard here, there's actually a caps lock button. And I'm going to turn that on now. And well, let me show you it with it not turned on. If I type in list, press enter, I don't get an error. That's because that's a valid basic command. If I hold down the caps lock and do it again, as you can see, it's in uppercase and the command works exactly the same. So this shows that the Apple IIe has support for lowercase characters in basic. But as I said, when we're trying to use DOS commands, we've got to make sure that we are using only uppercase. So it's a good idea on the Apple IIe to at least to turn on caps lock when you're trying to do that. Okay, with all of that said, a finer point also of using Apple DOS is that the slots and the devices can also be specified in commands. So for a different slot, you would specify S and the number of the slot, and for devices, you specify D and then the device number. Also, you've got to remember that Apple DOS has the concept of default slot and device values. So for instance, if you have a card in slot 6 here, as we have here, and it's booted up from device 1, right now Apple DOS has a default slot and device of 6 and 1. That means most of the time when we're dealing with a single card system like we have here, you can basically forget about the slot command. But we do actually have another device plugged in here. We've got the floppy emu. So if we want to, as an example, get the contents of the physical drive here, we would type in catalog and just press enter, because right now the default is for slot 6 and device 1. And if we wanted to get it off here, we would have to type in catalog, comma, D2 to get device 2. The default is already slot 6, so we don't actually have to specify that as well. So it is important that you're familiar with that syntax. We'll see how to use this a little bit later. I will actually copy some files from this drive here. Let's call it a drive because it's emulating a drive. So let me just give you a quick demo of it now, just to show you it actually working in practice. So if I type in catalog, press enter, the drive activates, we get a catalog of this disk. Now in the floppy emu right now, I actually have the disk image from which this master disk was originally copied. So I can get a catalog of that, which will be exactly the same as this disk. But to do that, I have to tell it to look at device 2. So catalog, and then a comma, and then the device number like that. And now I can see the tracks on this flashing, and it's giving me a listing of that disk. And there we go. It's basically the same as what we have here. If we had another card in this slot here, let's say slot 5, and we plugged this into there, let's say in device 1, we could get a listing of this by typing in catalog, comma, S5, comma, D1, slot 5, device 1. So hopefully that explains the whole slot thing. As I said, I need to explain that because as we move on, we will use commands, and at some point I may have to use, let's say for instance, this device here. And another quick explanation is required about binary versus basic files. Now, saving, loading, and working with binary files is outside the scope of this video, but as you will need to load binary files, we need to address this. So Apple DOS does not treat these two file types as interchangeable. Instead, you need to run slightly different commands when you save, load, and run each type of program. So for basic programs, the default names are used. So for example, if you want to load a basic program, you would use load. If you wanted to save it, you would type in save and then the name of the program. But if the program was a binary file, in other words, if it was something that you'd written in machine code, and obviously a lot of software is written like this on the Apple II and most computer systems. In fact, these days, everything basically is binaries. Then you would need to use the bload command. And as you can imagine, the B in bload stands for binary. Now, an example of this would be the FID command. So you can see there FID. That's actually a binary file. And I believe that if we look here, it says B. And I'm assuming that that means that it is actually a binary file. So yeah, if you wanted to run FID, you would need to use the brun command. So with that out of the way, let's take a look at the main Apple DOS commands that you may need to use. The first thing that we're going to do is we're going to initialize a new disk, and we're going to use the init command to do that. So for example, let's say we have this disk here, and what I'm going to try and do is I'm going to try and build a small copy of the master disk that we see here. So we're going to take out our master disk. I'm going to pop this in drive 6.1. And right now, we are using this drive, I believe, as the default device. So it'll be device 2. So if we typed in init, we'd actually end up blanking this disk here. So what we want to do is type in catalog and comma device 1. There we go. And as you can see, it's already got some data on it. We're going to wipe that data by typing in init. And let's call the disk boo. So it's using the default slot 6, and I've changed it to device 1 just then by cataloging it. So that makes sure that it's actually going to initialize this disk. Takes a few seconds for it to complete. Okay, there we go. That's finished. So let's do catalog to see the contents of the disk again. So there we go. That, by the way, that command catalog, that would have been so amazing if you were a tape user back in the day. That alone, I remember on my Commodore 64, just being able to list the contents of a disk and easily see them, and then, you know, to be able to then carry on and do the other DOS commands was pretty amazing, yeah. Okay, so that's great. So what we're going to do next is we're going to copy a file off here, and we're going to put it onto here. Now the copy command is only accessible using the FID utility, so I'm not going to use that to do that. What I'm actually going to do is I'm going to load the basic command, which is called the hello command, which is a default file that can be loaded automatically when you have a master disk. I'm going to load that off here because it's actually written in BASIC. And then what I'm going to do, I'm going to have that in memory in the Apple II, and then I'm going to write that back out to this disk here. So for that to happen, I need to say that I need to load hello from device number 2, this device here. So let's do that. Load hello and then device 2. Press enter. And I can see the tracks on here moving. It says that it's done. So if we list it, there we are. Doesn't all fit on screen, but basically this is the piece of software that produces the display when I actually booted up this master disk. To get a sort of functional copy of this disk, there are a couple of other files that I need to copy as well, and I'll show you that in a second when we get to the FID utility. But what we need to do now is to save this out. I'm going to call it, let's call it loader, and I'm going to write it out to device 1, because we loaded it from device 2. So right now our default is device 2. We're going to save it to device 1. I can see the disk is running. So in a second, that should be complete as it is. And what we've done then is we've loaded in hello from device 2, and that's loaded into RAM, and now we've saved it to device 1. So if we catalog that, there we are, we've got bootloader. So now we've used the load command to load in a basic file, and we've also used the save command to then save out a basic file. There is obviously bsave, which is to save out binary files, but as I said, we don't really have the time to talk about that in this video. But anyway, there is bload and there is bsave, and those are obviously useful when you've written something in machine code or if you need to load up a binary file. So running a file, that's pretty cool, because what it allows you to do is you can actually use it as an alternative to loading. And what it does is it will implicitly load a file. In this case, it would be a basic file. And then it will execute that basic file using the, well, you can imagine the basic command run. To show you this, I'm going to run this file, okay? So what we can do is we can type in load, loader. So that's going to load it off the disk. It's loading, there we are. If we list it, there it is in memory. And if I run it, it will now run it from memory. And it's as if we're actually booting up from our master disk again. Now the problem is there are a couple of files missing off this disk which are on here, which is why we got this error. But anyway, let's do that again. But instead of loading it and then running it, let's use run. So run, and then the name of the file. So it's actually very similar to the basic run command, but that will actually run the basic program from memory. But in this case, we're actually going to run it from disk, as it were. So it's going to load in loader, and then it's going to run it. There you go. So that's the same, as I said, as actually, actually loading it up and then running it. Okay, so that's what run is. And if you want to load in a binary file and run it, you can imagine that you use the brun command. This is easier to use than using bload, because when you do it, brun has the ability to actually look at the headers of the binary file, and in the headers it actually says where it will actually be loaded into memory, so that once it has finished loading into memory, brun can then start execution from that point, and it will then automatically run that software. So we're going to use brun a little bit later in this video when we load up fishhead, FID. Pretty cool. So next we're going to do delete. And for that, let's just make a file. So I'm going to reboot the machine. Let's just clear the memory. There we go. Saving to disk. Takes a few seconds, and if we type in catalog, there we have our program. And what we're going to do now is we're just going to delete it. Actually, no, tell you what, we'll rename it first. So let's rename proggy to my proggy. There we go. There's my proggy. And as I said, if I wanted to load it, let's just restart the machine. It's still going to fail because we're missing the files off the disk. So if we catalog the disk now, there we are. And if we wanted to, as I showed you earlier, I could load up my proggy. Now, I don't want that on the disk. So what I'm going to do next is I'm going to delete it. So let's do delete and my proggy. There we go, and it's gone. And the last thing I'm going to show you is, well, at least out of the main commands, is what I did there was obviously something that you wouldn't necessarily want to happen. You may want it on occasion that any of your files are protected, basically write protected, so you can actually lock files and then in turn unlock them as well in Apple DOS. So to do that, we're just going to, let's have a look. We've actually got our loader there, haven't we? So let's lock that and then we'll try and delete it. So lock loader, and then we'll catalog. And you can see that it's locked because if you have a look at it here, it wasn't locked and now it has an asterisk next to its name, and that means that it is actually locked. So if we now try and delete loader, you see that the file is locked and we can't actually do that. So right now, when we reboot this machine with this copy of, well, with this initialized DOS disk, we do actually get the DOS commands. We don't have the FID utility, for instance, which is on here, and various other bits and bobs. And to do that, you would have to copy pretty much everything across from this disk. However, you can actually get it so that it will actually boot up this loader file automatically. And to do that, we need to convert this disk into a master disk. That won't be quite the end of the story, because with this particular loader, which is just a basic program, it does have a couple of commands in there to load up basic. And for that to happen, we have to copy another couple of files across from this disk. So we'll do that in a second. But first, we'll convert it into a master disk. So for that, we need the master converter. So for that, I'm actually going to load that from here. So I'm going to do binary load, bload, master create. I believe it's called master create. And we're going to load it from device number 2, because in here, as I said earlier, we have our master disk. So let's load that. Looks like it's working. Not sure why that didn't work. Maybe because we didn't actually boot from this disk. So let's actually let's try that again by rebooting. And this time we'll actually just boot off this one, which has all the files on it. Okay, so brun. Actually, that's what it was. I used bload. I should have used brun. So brun master create. There we are. This should work this time. It's actually going to load it up and then execute it. Last time it loaded it up and it was waiting for me to execute it, but I didn't know where it was in memory. So yeah, that really wouldn't work. So it's asking me what the greeting program is. Now on the master disk, it's actually called hello. But as you saw earlier, when we saved it out, we saved it as loader. So we're going to call it loader. There we are. It's asking us to get ready with the disks. So what we need to do is put in the other disk. Now you can see that with all this disk swapping, this is why people actually bought multiple disk drives. So let's just press enter. What it's doing is now it's updating the DOS on the disk so that it will actually try and load from loader. We should then basically have a disk which will actually boot up this hello program. In our case, it's called loader. So let's just reboot to do that. But the only problem is, as I said, there's a couple of pieces of software still missing off it. So we need to copy those across. And for that, we're going to have to use FID. There you go. It's going to say file not found, break in 60. So if we have a look at list and we have a look at line 60, see here it's saying bload loader. That's because that doesn't actually exist on this disk yet. So let's actually get that. So we'll do brun FID, this time device 2. So we're loading up FID off here. There we go. I'm going to press 1 to copy files. And I'm going to go from slot 6, device 2, to slot 6, device 1. So in other words, from here to here. We've got our disk in already. So the file that we want to copy is called loader.obj0. And I pressed enter. There we are. And now that we've done the copy command once and set up our drives, that will actually work again. If we copy again, it won't ask for that again. Now it's just asking for the file name. So that's a little mercy. It's a little bit faster now. So the other file that we need to copy is actually the integer basic, which is what loader obj0 is trying to load up. So we need to type in int basic, press enter. It's now going to copy it across. There we go. And it's done. So now we can restart. And what we should find is that the machine should actually boot up with the same sort of splash screen, as it were, as the original master disk. There we are. And there's not going to be an error. And it's saying loading integer basic into memory. And it's ready to go. And if we catalog the disk, we should find, there we are, we've got our loader file which is the same as the hello file on here, except we renamed it. We've got the loader obj that we just copied across, and we've got the int basic. So this hello file is an interesting feature of AppleDOS because it allows you to basically make the disk bootable into some kind of software. You can basically have that basic program kick off another binary program by using, for instance, brun. So yeah, your basic program could be very, very simple. The first line of it could be brun, load in this binary file into memory and just execute it. Obviously, as you become more sophisticated as a programmer, there may be other things that you can do with it as well. I'm not sure, for instance, if you can have a binary-based hello file. That's an interesting point. If you're an expert in the Apple II, then maybe let us know in the comments. Anyway, there we are. That's a bit of a tutorial into AppleDOS, and it's certainly something that I would have loved to have known off the top of my head when I first picked up an Apple II. So hopefully if you're new to an Apple II, or if you're struggling with some features of it, that will have given you some help. Okay, well, that was a lot of stuff to go through. I thought we would talk about some of the games that actually took advantage of the system and what a difference they actually made to the whole ecosystem of gaming. And I don't just mean on the Apple II, I mean on all the platforms, all the micros from the early 80s. Before we do that, I'd like to very quickly talk about the floppy disks themselves. These are getting pretty old now, and to be honest, they were always a little bit fragile in the first place because of magnetism. So in terms of care, try to keep them away from magnetic sources. In my cabin, for instance, I have magnetic screwdrivers, you know, with the tips of magnetic, so I have to keep those away from the disks, otherwise that can cause the magnetic media to get scrambled, and that can obviously wipe data. An interesting thing about these is that many people, well, most people would think that when you actually take it out of the sleeve, that it's actually this top area here, that's actually where the data is going to be written to. In reality, it's actually on the underside of the disk where the head is inside the disk drive. So if you can imagine, when I slot it in there, there's actually a head that goes underneath, and it's that actually does the writing. There's a little felt pad that comes down from the top and actually clamps the disk very softly, and then the head actually goes underneath and reads and writes the data. Now, the interesting thing is there's a little notch here, and these disks, when they're sold, it actually says on here double-sided. So there is actual magnetic media on the top side of the disk as well, which means you can actually use it to store data on. And because of this, you have these little devices, notches, and what they allow you to do is to actually punch a notch on the other side of the disk over here. And that means then you can actually use the top side to actually write data to as well. So I actually haven't done it with this disk, so let me just do that now. So I'm just going to pop it into the notcher here, and then I'm just going to push down quickly. There we are, and it's cut out a little notch there. And now this disk is actually double-sided. I can actually use both sides to actually store data on. Now, when the notch is there, it means that that side of the disk is readable. So if you can imagine, when you put the disk in like this, it's this notch that means that the underside is readable, and when we flip it over, it's now the other notch, the one that I just made, that now means that the other side is readable. So yeah, that's an interesting point to remember. So if you do buy any of these disks and you find that they're not notched on this side, you can either do it with something like a scalpel, for instance, which is a little bit tricky because there's a piece of like felt inside these, which is quite hard to cut. So what I would do is I would have a look on eBay and see if you can get hold of one of these, because these make the whole thing a lot easier. I think this was about £15. So yeah, magnetic media. I love it, but it is a little bit fragile and you do have to look after it. So the Apple II disk drive, the Disk II, I think it's a very important peripheral in terms of early microcomputing history. And the reason for that is that it established a very professional system on the Apple II very early on in its life. You know, all the way back in 1978, just 1 year basically after the Apple II came out. And the provision of this drive then, of course, freed up people to make video games, for example, that were in advance of anything that was possible on tape. Now, it's not the only advancement that you need to make more complicated games. You also need memory as well. And it's probably for that reason that it takes a couple of years more for you to start to see more complex games appearing on the Apple II. I'll give you an example of what I mean by a more complex game. Zork 1. Now, this was originally written on a mini computer. I think that computer had something like 2 megabytes of memory. To get it to run on a microcomputer, the people at Infocom had to wait until the Apple II had enough RAM to make it viable to get this game to run. But that's not the end of the story, because the game actually uses more than 48K of RAM. And the way that it does this is it actually loads data off the disk as you play the game. It's very, very clever, and I will do a video on it in the future. So basically, as you're playing the game and you're typing in commands, it will load up new locations, and it will load up even commands, things that you type in. For instance, you might type in look, and the game may not have that in memory. So what it will do is it will actually load up that command and then execute it, and then, for instance, load up that part of the game. So this is a game that I'm a big fan of. It really, I think, kicked off text adventures, and coming from a Commodore 64 background, I had to wait a number of years until I could get a disk drive, and it was only then I could actually play Infocom games, because they do actually require a disk drive to play, basically. So yeah, a very important game, I think, in the evolution of video gaming. And I would say it was the sort of start of role-playing to one degree or another. Having said that, there were the Ultima games, and we're going to have a look at those in a second. For instance, in 1979, and I don't actually own this game, I only actually own a trilogy, a box set. But one of those games, Ultima 1, and again, it's another game that requires a disk drive to load in locations and so on and so forth. So again, a game that was basically liberated. The idea of doing it was liberated because of the flexibility of using a disk drive. Later games in the series, for instance, Ultima 2, which came out in 1982, was quite a big advancement on it. And the first game that I actually played in the Ultima series was Exodus Ultima 3, which I first played in 1984 when I got my disk drive for my Commodore 64. And that was basically a direct port of the original game written on the Apple and released in 1983. And I honestly think that this game really did sort of kick off role-playing games. So you can, trace back some of its heritage to the text adventures, but it is its own thing because it is actually a graphical role-playing game. So yeah, an incredibly important game in terms of the history of video gaming. If you like Fallout, for instance, and you can probably see behind here that I'm a big fan of Fallout and other role-playing games, the Baldur's Gate games and things like that. Well, you can trace it all the way back to Ultima 3, 2, and 1. So yeah, incredibly important, and it did get written on the Apple II. Another interesting game is Bill Budge's Pinball Construction Set, released in 1982 on Budgeco originally, which was Bill Budge's own label. And then just a year later, it was picked up by Electronic Arts and released in this really fantastic package here, which is a little bit sort of like a vinyl album. And inside it actually has artwork which shows Bill Budge. There he is here with some white gloves on and a sort of chrome ball. Why was this important? Well, this was, I believe, the first game ever where you could actually make games. So it was a game construction kit, as you can imagine by the name. And again, it's the kind of game that just wouldn't have been possible on tape. Loading up your assets, your various pinball tables, saving them out, sharing them with your friends on a floppy disk. It just wouldn't have worked on tape, honestly. It would have been horrible, but this was rather fantastic. Unfortunately, I didn't have any other friends who were into pinball. I did have a go at making a couple of tables, but not particularly seriously. But yeah, a fantastic title, showing you again how important the disk drive was in the early days of gaming. And there's just one last game I'd like to show you. And again, this is a personal favorite of mine. It is the Bard's Tale series, or actually it's actually called The Tales of the Unknown. And the first game in that series was called The Bard's Tale. But basically that stuck in people's mind, and from then on it was called the Bard's Tale series. Again, a floppy disk, a fantastic game. This takes some of the ideas from the Ultima games. You have 3D mazes, but the graphics are much, much better in the Bard's Tale. Sort of more realistic realizations of the environments that you're traveling through. And when you meet monsters, you get really nice graphics like this here, showing the dragon and sorcerers and things like that. So a slightly different branch on the tree of role-playing, but again, an incredibly important one, and again, developed on the Apple II. So the Apple II was basically the source from which graphical role-playing games sprung. So we can trace back games such as Fallout, Starfield, etc., all the way back to games like The Bard's Tale, the Ultima games, and so on and so forth on the Apple II. So anyway, I hope this video has been useful to you. I found it very interesting doing some of the research. One of the reasons why I did it is that I learned many years ago that one of the best ways of learning is to try to teach. And when you actually do the research to teach people, you can then learn things about what your actual subject is. And I found it was very interesting to find out about Apple DOS and its various quirks. Now, in the next video in the series, what we're going to look at is its direct successor in terms of hardware and also in software as well. Let me just grab a drive over here. So this is the Unidisc 5¼ disk drive. It is the direct successor to the Disk 2, and it was released in the early 80s. And I would actually probably recommend getting these drives if you're thinking about getting drives for the Apple II, because I believe they're a little bit cheaper and I found them to be a little bit more reliable than my actual Disk 2 drive. Having said that, it could be my individual drive itself that has a bit of an issue. There is only one problem though. If you do get one of these, then you do have to get a different interface card. And I found these to be a little bit more expensive to get hold of. But you may wonder how you can actually get multiple drives. You can see that it only has one connection on there. Well, you can actually daisy chain these. So if you actually have a look at the back there, there is actually a port where you can plug in another one of these drives. And the reason why I would recommend getting one of these more than anything is that the connector on it is completely unambiguous. It's actually a DB connector on there, and that means you can't plug this in the wrong way around. So you will probably find that in the long run, it's actually cheaper to get one of these drives. But anyway, it's up to you. But yeah, I have a number of these, and I only actually have one Disk 2 drive. So yeah, an interesting thing. And we'll be looking at that in the next video. And we'll also be looking at a new DOS that was released called Pro DOS, which went on to become basically the de facto DOS, which is used on the Apple IIs. Having said that, earlier games were developed using Apple DOS, and that's why we had a look at that today. And many of the commands, I believe they're basically interchangeable between the two. However, Pro DOS is its own beast. It's a much more capable DOS. It does take up a little bit more memory as far as I understand it, so you probably would use it on a machine with more RAM. Anyway, we're going to look at that, as I said, in the next video, so let's not talk about it too much here. I hope you enjoyed this video, and if you did, then please make sure you click on the like button. Otherwise, this video won't be seen by other people. YouTube won't actually recommend videos to people if people don't like them. So please take some time to click the like button, and that will help it get out there. Also, if you can, please hype this video. Hyping is a new feature that YouTube has added. And if you can hype my video, it will really help it go up the ranks. And again, get sent out to other people who are interested in the Apple II, the Disk 2 drive, and so on and so forth. And if you haven't been here before, then please make sure you subscribe to the channel and also click on the bell so you get notified when new videos get released, especially in this series, because as I said, there's going to be a new video out pretty soon on the Unidisc system and also on Pro DOS. So yeah, that'll be quite good fun, I think. Anyway, until then, have a good day and take care.